Okay. All right. So then we'll do the same thing for the next row and the next row. So 3, 1, 1, 2, and 0. There's no X in that last one. Did you catch that?
Yes.
All right. So we know we're going to put that matrix into our calculator. We're going to RREF it and end up with a new matrix, which is going to give us our answer. Okay? So to put the matrix in, we go to second matrix and click over to edit and then hit enter. Now the first thing that has to go in, you don't start putting these numbers in yet. The first thing you have to do is tell the calculator how big a matrix you're putting in. So how many rows do we have?
We have 4.
No, the rows go this way. Watch my hands. Rows. There's 1 row, 2 rows, 3 rows. Okay? So there's 3 rows, so 3 enter. And then there are 1, 2, 3, 4 columns. So 4 enter. So it's 3 by 4. All right? Now, as soon as you put in that, then the calculator's all set up, ready to go. Just type in your new numbers. Don't worry about any numbers that are already in there. Just type in the new ones. And make sure you hit, after you put in that 22, make sure you hit enter. And then you remember what you do?
No, I forget.
All right, then you're done. You're done putting in numbers. So you're going to second quit. You're going to just quit. You're done putting in the numbers. You finished that. So you're going to quit that procedure. You're done with it. Then you go back into matrix. So second matrix. And now we're going to do something. We're going to do some math. Particularly, we're going to RREF, reduced echelon form. So we're going to go over to math. And then all the way down till we find the RREF and hit enter. And then one more time we go second matrix back into the matrix menu and just hit enter. And that will get matrix A, which is what we call this. And then hit enter again and it will give you the new matrix. It's going to give you your answer. Oops. And the new matrix looks like this. What you should see on your screen right now is this. Is this what you see?
Yes, that's what I got.
All right. So then this column right here, this last column, that is your answer. So if there's an answer blank, that's what goes in the answer blank. And this is the work you show right here. That's all you have to show. Matrix that goes in, matrix that comes out.
Okay.
Because the calculator does everything else. All right. Now we're going to do a couple with Kramer's rule. Now this is not on the calculator. Okay, we don't need a calculator for this. We're going to do Kramer's rule. Now, I know that you could do substitution or elimination on these, but that is not what we're supposed to be doing now. We're doing Kramer's rule. And Kramer's rule, we haven't done that in a couple days. Kramer's rule is that rule where we use determinants. So we start by setting up a determinant, that's the vertical bars, with just the coefficients. So just the x's and y's, all right? So we're going to have 1 minus 3 and 5 and 4. Now we're going to evaluate that determinant. We're going to figure out what that equals. So remember, that's the down minus up thing. So multiply down, we get 4. Multiply up, we get negative 15. But remember, we subtract those two numbers. So we get a 4, and we get a negative 15, but we subtract, so our answer is actually 19. Do you remember that?
Yeah.
Okay. Now, the answer to the question is going to look just like the last one we did, except there's only two numbers. There's just an X and a Y. But they're going to be fractions. And the denominator of the fractions is going to be 19. So like 5 over 19 and 8 over 19, something like that. We have to figure out what the numerators are. So the numerators, there's one for X and one for Y. Those are other determinants, just like this one. Do you happen to remember how we build the X and Y determinants?
We have to use like the first problem, right?
Well, like this, yes, we use this.
Yeah.
But we take the 9 and the negative 2, and if we're doing the X determinant, we paste these numbers on top of the X's. So we'll have 9 and negative 2, and then negative 3 and 4. So pretend that you can cut that out and just glue it right here. So your determinant would be 9, negative 2, negative 3, 4. If you're doing Y, you do the same thing, but you cut these out and paste them on the Y. Remember, these were the X numbers and these were the Y numbers when you took them out of the original equation. So if you're doing Y, you're going to paste those on top of Y. So you would have 1, 5, 9, negative 2. Don't switch anything around. Don't do anything except paste that right on top of whichever letter you're solving for. And then we evaluate these just like we did that one down there. So we multiply down, 36, multiply up, 6, so 36, 6, and then we subtract. So that numerator is 30. Now you do this one. What's that numerator going to be?
So the first one would be negative 2.
Yep.
And then the other one, 45.
Yep.
And then so it would be negative 2 minus 45.
Yes, it would be.
So negative 47 over 19.
Yep. And that is what goes in the answer blank. Now, sometimes you can reduce those, so you always want to reduce them if you can, but that obviously doesn't reduce, so that's it. That's the answer to the question.
Okay.
Now, the next one is exactly the same thing. We're doing Kramer's rule, system of equations. So you work on that one for a minute, and let's see how far you can get.
Okay.
Do exactly the same steps. tell me when you get your denominator figured out. Remember, your denominator comes from the coefficients.
My denominator was 13.
All right, let's check it out. We get negative 25 and negative 12. And since we are subtracting, that's going to become negative 25 plus 12. I got negative 13, Vincent.
Wait, how? Oh, I didn't make my 25 a negative.
It should be a negative, right?
Yeah.
Yeah. And the 12 is negative, but you're subtracting it, so it actually becomes a plus.
Yeah. Okay, I messed up. I forgot to put the negative 5 in the denominator. Okay, let's finish the whole problem.
Okay, all right. Let's see what you got.
I finished with negative 25 over negative 13 and 56 over negative 13.
Now, you are absolutely right. There's just one little tiny correction that I'm going to make. Otherwise, you are exactly right. You did it perfectly. So you put a 110 here and a 2 negative 5 here. So we got negative 5 minus 20, negative 25. That's beautiful, beautiful, beautiful. And then you had 5 negative 6, 110. So that was 50 minus negative 6. So that's how you got 56. Absolutely lovely. The only thing I can say is, right here, whenever you have a negative over a negative, you should cancel those out. So that's just a little simplification thing. But otherwise, yes, you did that absolutely perfectly. All right?
Mm-hmm.
So that takes care of the homework. Yeah.
For the quiz that's coming up next week, is it gonna just be like over these last 3 like homework stuff we've done?
It is over what the problems that we practiced yesterday. So if you look at that piece of paper, I had you get out a piece of paper, or that's what I wanted you to do anyways, just work on a piece of paper.
Yeah.
So look at that piece of paper, and we can do another one of anything that looks like you don't remember what you're doing on those.
Okay.
While you're doing that, hang on a second. I'm gonna put that homework in for you since I know you have it done.
Okay.
Yeah, all right. You don't have to send it in. I just put it in. All right.
We did the one where it's like, there's a whole bunch of different steps. Like A was the, like kind of what we just did, and then there were B. You know what I'm talking about? It's like B is like dimensions of A, and then C is A plus C, and then D is AB.
Yeah. Which problem is it? Those were all separate problems.
It was negative 1, 1, 5, and then 302.
Yeah. No. What do you want me? Which of those? when you said we had A, B, C, and D, those were separate problems. Which one of those do you want to do?
Can we do the B, like dimensions of A?
Yeah, so just finding the dimensions of a matrix. So that's, there's no mystery there. That is really easy. Let's say we have this. Okay. Dimensions are rows by columns. Okay. So just take your pencil. That's row 1. This is row 2. So I have 2 rows. Column 1, column 2, column 3. I have 3 columns. So that's a 2 by 3.
Oh, okay.
That's all there is to it. So rows, just think of the gym and the bleachers. These are rows of bleachers. They go sideways. Okay? All right, that's all there is to that. So the dimensions are just, you don't do any math, you just count, basically. So it's rows by columns.
Okay. So, let me see.
I'm trying to think. Another question, if this, let's say this right here is matrix F. Okay, let's say this is matrix F. If I had F, little f, and then a 2, 3, do you know what that means? What am I talking about? If that's matrix F, what am I talking about when I write something like this?
Is it that like 23 times?
No. This is not really a 23. It's a 2, 3. So this means row 2. It means row 2, column 3. So I come over here and I go to row 2. This is row 2 right here. And this is column 3. So what number is in row 2 and column 3?
2.
Yep. So that's the answer to that. So again, no math. So these 2 questions have no math to do. You just have to basically count to see where you're at.
Okay, right. And then like the one where it's like A plus C, is that like where you add both of those column things together?
Yeah. So if, let me use a different letter. So if this is matrix D, and this is matrix F, and we want to add them together, we can do that because these are both the same size. In order to add, they have to be the same size. They have to have the same dimensions. And then to add them, you just add the numbers that are in the same spots. So you're going to add those 2 together, and that gives you the 2 that's going to go right here. And then you add these 2 together, and that's going to give you a 1 that's right here. See what I'm doing?
Yeah.
Yeah, and then 5 and 3, so this would be 8, 4 and 5, 3 and 7, 2 and 2. And so that's all there is to adding. Remember, however, you can't do that unless they're the same size. As long as they're both the same size, you can add them.
So when it says like just A, B, is that where you times it?
That's a multiplication. And these 2, I'll need another matrix because these 2 can't be multiplied. Because this is a 2 by 3, 2 rows, 3 columns, and this is a 2 by 3. And the rule for multiplication is these 2 have to match.
Okay.
And they don't. So I can't multiply those. That would not be possible. But let me put another matrix up here.
So like 3 by 3, both of them, could you multiply?
Yep, as long as these 2 middle numbers match. That's the only rule. We don't care what the outside ones are. The middle ones have to match. So let me put a matrix G up here. All Now, let's multiply G times D. Now, G is a 2 by 2, and D is a 2 by 3. So I can multiply a 2 by 2 times a 2 by 3 because those numbers match. And then these numbers, I don't care what they are, but they tell me how big my answer is. So my answer is going to have 2 rows and 3 columns. It's going to be the same size as this one, 2 rows and 3 columns. Now, let's review how to find these numbers, and then I'm going to set you loose and let you work on them, finish them up on your own. But let's do a couple together. So I got to find a number for each of these spots. So I'm going to be organized. I'm going to start right here. And that number right there is in the first row, first column. So I'm going to multiply my first row times my first column. So it's always rows here, columns here. Always, always, always. So I take my 1 and my 5. That's my row. And I'm going to multiply it times the 1 and the 4. So I keep them in order. First number, second number, first number, second number. Now I multiply each pair and add them up. So 1 and 20, that's going to make 21. And then I move over here. Now I'm still in the first row, so I'm still going to use my 1 and my 5. But now I'm in the second column, so I'm going to use -1 and 3. You see what I'm doing?
Yeah, I do.
All right, so that's going to be 14. Then you go ahead and see if you can fill in the rest. Now, remember, when you get down here, now you're in the second row, so you'll be using -20 when you're down here.
Okay.
All right, so go ahead and fill those in. Let me know when you got them all filled in.
Okay. So, Miss, for the second row, it'll be, you start off with like -2, and then with 0 be in the parentheses?
No. When you're doing the second row, you write down, okay, so wait, what did you get here? Let's finish up this one first. What did you get here?
13, right?
No, let's go through that. So we're starting, sorry about that, we got the speaker going for some reason. We're going to use the first row and the third column. So the first row is 1, 5. So we'll try writing that down. 1, 5. And then next to those, I'm going to put 5, 2. And then I add them together. That's going to be 15. Now, when I do the second row, I do it exactly the same, except my red numbers are -2 and 0. And then I'll put in, for the first one there, I'll use 1, 4. So that one should actually be a -2.
Yeah, because the 0 cancels
Yeah.
out. Okay.
All right, so go ahead and see if you can get those two.
Okay. Was the last two and -10?
The last two are 2 and -10. Yep, that's exactly right. Good job. So you got that figured out now?
Yeah.
That's matrix multiplication. Okay, good. All right, we got time for one more problem. Let's try this. I'm going to use matrix G that I've got right there. And let's find G inverse. Okay, so we're going to find G inverse. Okay, so this is matrix G, and we're going to find the inverse. Now, this is a two-step process. Okay? So, do you remember what the first step is?
No, I forget.
Okay, well, first step, we want to find the determinant. So we've practiced that. You should know how to do that. We're going to find the determinant.
That's column by rows, right?
No, that would be dimensions, and it would be row by column. But we're finding the determinant. So that's where we do the down minus the up.
Oh, okay.
So
Yeah,
0.
so
No, 0.
0, because it's multiplication.
Mm-hmm. Yeah, you're multiplying, yep.
And then -10.
Okay, and then we subtract those though. So it's actually
so
going to be
10.
positive 10, right. Now we hang on to that. That's step 1. Now step 2 is you're going to build that new matrix. And the new matrix, we take these two numbers and we flip-flop them. So the 0's here and the 1's here. Remember this from the other day?
Yeah.
All right. And then these two, we leave them where they are, but we make them opposite. So the opposite of -2 is +2, and the opposite of 5 is -5. So these two switch, and these two become opposite. Now, do you remember what you do to finish up? You're almost done.
You have to don't you have to multiply those again?
No, what we do now is we take each of these numbers in the new matrix and put them over 10.
Oh, yeah.
And then we reduce anything we can to when we put it in the final answer blank. So 0/10 is just 0. -5/10 would be -1/2. 2/10 is 1/5. And then 1/10 is 1/10. And that would be the answer to the question.
Okay.
Now, Vincent, that's all we have time for this morning. I just had another kid come in here. So what I need for you to do is go back now and spend some time re-practicing the practice problems we did yesterday and the ones we've done this morning, okay?
Okay.
Now, the practice problems we did yesterday are in Schoology. They are in the Chapter 7 folder where it says Extra Practice Review.
Okay.
All right, so if you didn't have them copied down or if you just want to print it off and do it again, you can do that.
Okay.
All right, you're welcome. Have a good day. I'll see you later. Maybe, I don't even know.
Okay, and Miss Ford,
Yeah.
Do you know when a good time to make up that quiz would be or test?
Yeah, the makeups for that are Tuesday after school. So
Okay,
can you
thank
come
you.
in? Can you get here after school sometime?
Yeah, I will.
All right, see you then.
Okay, thank you. Bye.
Bye. Okay, all right, so let's put you, because I'll be having Alpha starting here soon, so let's put you, crosswalk in your phones here.
Yeah.
All right. Oh, let's turn this off. We don't need